Hi, my name is Nat Waterworth and today I'm going to talk to you about three things. The implementation of computer vision techniques in Space Rock Rythym, how this game meets the client's requirements, and potential future improvements on this project. So, starting with the OpenCV techniques, we have colour matching. Using a blue object and a green object, we can match the colours of coloured objects as they approach the detection area. This works as a colour mask is defined using a hue, saturation and value range. With that colour mask, the colour-specific contours are identified, which indicates the presence of a coloured object, the largest of which is used to determine the player's input for the game. Additionally, as the two coloured objects incapacitate the player's ability to pause the game, I implemented a pause mechanic using a large coloured area, which also comes in use if the player is not using their camera space very well. However, a weakness to this method is that it can be largely dependent on lighting conditions to function, and also lighting has the potential to alter the colour of light reflected from the surface of the objects. Next we have an emotion matching mechanic where the player must match the emotion that pops up on screen with their own facial emotion. This functions using a Haar cascade frontal face classifier to detect faces. Then, using the largest face detected, it utilises a facial emotion trained classifier to identify the most present emotion on the face. And although this matching mechanic works particularly well for me, when testing on other people, facial accessories such as glasses have proven problematic as the model wasn't trained with those in mind. Also, there is face tracking. As mentioned before, using the Haar Cascade frontal face classifier, faces are identified. Then, using the face's 2D position and size, we can translate that information into 3D positional data. This has been used to give the game an immersive feel similar to VR, where the movement is in all three dimensions and changes the player's perspective. Additionally, it has been used in the bonus round to steer the spaceship through side-to-side head movement. An honourable mention is tile tracking using homography. Initially, I was going to use tile tracking to adjust the volume, however I wanted to ensure that settings could be adjusted without a webcam and physical tools such as a tile to track. So I kept all the webcam based interactions within the game loop only. Plus, it restricted the flow of the game, as the player would have to set up and use a reference image to steer the ship, and it was fairly computationally expensive when used in conjunction with the other techniques. Probably most importantly, face tracking could achieve the same outcome and it had already been implemented within the game. So this game meets the client's requirements as a complete game loop has been created in which the player is challenged using interactive techniques which have the alternative audio and visual responses to positive and negative actions. The player is then awarded a final score and a chance to beat the saved high score. As well, the player has a range of difficulties to choose from, easing them into the game. And finally, the product functions on Windows operating system with additional features such as feedback space rocks, which mark the player's success with a representative colour and match the amplitude of a song with the brightness of the coloured rock. For the future of the project, I would focus on three things. I would create a toggle from within Unity to switch on and off computer vision algorithms that run in the Python application. This would be achieved creating a socket that reads information sent from Unity and would reduce the overall CPU usage at any one time. I would also make the game start the Python at OpenCV based application when booted so the player doesn't have to do it manually. And finally, I'd allow the user to alter the two colour matching object colours, as the player may not have those specifically at their disposal, or have the correct lighting conditions for the colour value range, which may result in false positive results or no detection at all. And as a last note, I have created a credit screen to show where all assets have been obtained, which I haven't created myself.